Hello everyone, welcome to our statistics channel, Quality Statistics. Today we will discuss quartile deviation. This is absolute measures of dispersion, and the another name of quartile deviation is semi-interquartile range. By definition, we can say that quartile deviation is defined as half the difference between the upper and lower quartiles. We get three quartiles: quartile 1, quartile 2, quartile 3, and here we need two quartiles only, that is quartile 3 and quartile 1. Quartile 1 is called lower quartile, quartile 3 is called upper quartile. Hence quartile deviation equals to Q3 minus Q1 by 2. The difference Q3 minus Q1 being the distance between the two quartiles may be called interquartile range, and half of this is semi-interquartile range. Semi denotes half. Thus the name semi-interquartile range itself gives the definition of quartile deviation. Now in next para we can say that quartile deviation is dependent on the two quartiles and does not take into account the variability of the largest 25% or the smallest 25% of observations. It is therefore unaffected by extreme values, since in most cases the central 50% of observations tend to be fairly typical. Quartile deviation affords a convenient measure of dispersion. Full stop. It can be calculated from frequency distribution with open-end classes. Quartile deviation is superior to range in many ways. Its unpopularity lies in the fact that quartile deviation does not depend on the magnitudes of all observations. The calculation of quartile deviation only depends on that two quartiles Q1 and Q3, which can be found from a cumulative frequency distribution. Now we establish problems on quartile deviation. Quartile 1, question 1, find the quartile deviation of monthly incomes in rupees 7 men given below. Rupees 350, rupees 840, rupees 650, rupees 710, rupees 980, rupees 575 and rupees 290. This is nothing but the example of simple observations. For simple series, arranging the given values in ascending order of magnitudes, we get 290, 350, 575, 650, 710, 840, 980. Here n equals to 7, number of observations is 7. Now quartile 1 equals to n plus 1 by 4th value, that is 7 plus 1 by 4th value, that is second value. Now quartile 1 equal to rupees 350. Similarly quartile 3 n plus 1 by 4th value. Quartile 3 equal to 3, 7 plus 1 by 4th, that is 6th value, that is 840. Quartile deviation equals to Q3 minus Q1 by 2 equals to 840 minus 350 by 2, that is equals to 490 by 2, that is 245. Hence quartile deviation is rupees 245. Now we go for the second problem, and the second problem is related to discrete distribution. That is, here heights are given 60, 62, 64, 66, 68, 70, 72, and number of students 4, 10, 18, 26, 20, 12, 5. We place here the heights are 60, 61, 62 here, and number of frequencies here, and cumulative frequency is there. Now Q1 equals to value of the n plus 1 by 4th item, that is value of the 24th item. Q1 is 64 inches here, and similarly for quartile 3 we get quartile 3 equal to 68. Here quartile deviation becomes Q3 minus Q1 by 2 equal to 68 minus 64 by 2 equals to 4 by 2 equals to 2 inches. Now we go for the third question, and it is related to grouped distribution, grouped frequency distribution. Here find the quartile deviation from the following distribution. Weights in kgs are given: 40 to 45, 45 to 50, 50 to 55, 55 to 60, 60 to 65 and 65 to 70. And number of men, that is frequencies here 10, 22, 28, 20, 12 and 8. We arrange this in cumulative frequency form, that is first frequency is 10, second frequency 22, and we get 10, 32 as cumulative frequency, again 28, and this becomes 60, and in this way we get cumulative frequencies. Total frequency is here 100, that is n equals to 100. To find quartile 1 and quartile 3, we get n by 4 equals to 25 and 2n by 4 equal to 50 and 3n by 4 equal to 75. For quartile 1 group, we get the quartile 1 group, we get 45 and 50, 45 to 50. By using formula, we get Q1 equals to L1 Q1, which is lower class boundary of the quartile 1 group, n by 4, 1/4 of the total frequency, FCQ1, cumulative frequency just preceding the quartile 1 group, FQ1, frequency in quartile 1 group, and I is the class width. And by this situation, we put here 45 as L1 Q1, n by 4 25, FCQ1 10, FQ1 22 into 5, and we get 48.40 kg. The value of quartile 1 48.40 kg. Similarly, we use for quartile 3 L1 Q3 plus 3n by 4 minus FCQ3 by FQ3I, and we put here the values and get Q3 equals to 58.75 kg. Now the formula quartile deviation equals to Q3 minus Q1 by 2. By putting those values, we get 5.175. Hence, quartile deviation equals to 5.175 kg. These three types of problems are total complete problems for three series: for sample series, discrete series and group distribution series. This is all about today. Now keep watching our channel for new videos and new topic, and next topic will be standard deviation, and wait for the next video. Thank you all for watching this video.